Hey guys, so let's discuss new round, which is round 4, and it is AI engineering. Okay, so the question is given to you is let's say Amazon want to build an AI shopping assistant. Okay, so AI shopping assistant means you can ask question to that shopping assistant, and it will provide you the response. Okay, so the assistant should answer product questions. Okay, you can ask product related questions, and then compare products, recommend products, and explain reviews. Okay, short summary, and then track orders and answer delivery questions. So all these kind of things, he will help you to give you answer. Okay, so now the round is becoming increasingly common for backend engineer interviewing in 26. Okay, and the interviewer is not expecting you to train the LLM. Instead, they want to see whether you can design production ready AI application using LLM, RAG, vector databases, API, and modern AI infrastructure. Okay, so here you don't need to train one LLM model from scratch. Okay, you just need to use existing one or use the existing APIs. Okay, and then use the RAG, retrieval augmented generation, things into that. So now again, the expectation differs by level. Okay, so for software engineer, understand AI component and build a basic RAG application. That is what expected. From senior software engineer, design a scalable production architecture with integrations. Okay, and then from principal or architect, build an enterprise grade AI platform with the governance, security, observability, and cost optimization. So all these things you need to consider. So now what software engineer will answer for this question? Okay, so we will have three roles: software engineer, senior software engineer, and architect. So software engineer is 3 to 6 years experience. Okay, and then senior software engineer 7 to 12 years of experience, and then above that architect. So what software engineer will answer for this? Okay, so he will say that I would design assistant using retrieval augmented generation track. Okay, architecture, instead of relying on the LLM, product detail, reviews, inventory, order status are dynamic. So retrieving fresh information before generating response improve accuracy. Okay, so you have a let's say you have a model, and you have trained that model from pre-existing data. So but now see, your product information will change. They are dynamic, right? Which all things are dynamic? So product detail is dynamic, then it's a reviews are dynamic, right? A new customer, new person, customer will add new reviews. Then inventory is also dynamic. Okay, the count will change. After that, order status is also dynamic. So you cannot rely on the pre-existing data, pre-trained data, right? So you need to have that RAG layer in between, where what you will do, you will first store all the information into the vector DB. Okay, in the form of embeddings. Embeddings means text into numeric format, and then after that, user will question. Okay, so that question, it will again convert into the embeddings, and then it will fetch the it will fetch the response from vector DB. Okay, and then that response it will send to LLM, and then LLM will help you to send the response back to the user. Okay, on that data, so that LLM will not be able to hallucinate. Okay, it will give you the exact answer, the data what you have provided on based on that. Okay, the context you are giving him. So that is the thing. Now here is the high level architecture. Okay, so user will talk to shopping assistant. Now user will ask something to shopping assistant, and that question, so prompt builder will take that question. Okay, add some more rules on that, and then it will give it to retriever. Okay, will convert it to embeddings, and then will give it to retriever will retrieve data from vector database, and that data it will give it to LLM, and then LLM will give you the final response. Okay, so using natural language he will be assisting. Now what will be the flow? So user ask question. Okay, convert the question into embeddings, search the vector database for relevant product information, add the retrieved context to the prompt, send the prompt to LLM, and then return the generated response. So this is what I just explained. So example, which laptop is better for software development? So user is asking this question to our assistant. So he will say that laptop, so what he will do, he will take laptop A's specification, laptop B's specification and relevant customer reviews for both, okay? And it will send this information to LLM. So LLM generate a comparison using the retrieved information and then send it back to user. So now what senior software engineer will add here, okay, more in this. So this one is expected with him, whatever we have just discussed. And apart from that, he will say that I would separate the solution into independent services. Okay, now he is talking about the architect level, like independent services for inventory, for order status and all, right? So for retrieval, recommendation, order tracking, inventory lookup and LLM orchestration. Okay, not everything in one, but he will just separate it. So this improves scalability, okay, allow individual services to evolve independently. So the architecture will be something like this, okay. User will send request to API gateway. From API gateway it will go to AI orchestrator. So now AI orchestrator will have multiple services, okay. He will deal with multiple services like retriever and then recommendation, order services, inventory, okay. So retriever will go to vector database, then embedding model, and then it will go to LLM, okay. After that this order service will go to order database. So something like this it will categorize into these many services. Now additional consideration, okay, what he will take. So conversation memory, okay, so the history also it will take into the picture, right? Then tool calling for real-time data if you need to call external tool, external API. Then prompt template, caching, observability, rate limiting and fallback when external service fails. Okay, let's say you're calling external service and but that will get failed, so you should send something to user, right? So you need to handle that fallback method. Now principal engineer or architect, what he will be answering, so expected answer would be, at Amazon scale I would build the shopping assistant as an AI platform. So now he is talking here about AI platform, okay, rather than single service. The platform should support multiple LLMs, reusable retrieval pipelines, governance, security, monitoring, and continuous evaluation. So the organization level things, which is common for all the projects. So enterprise architecture, how it will look like. So customer will send request to API gateway. From here it will go to API gateway layer and then LLM orchestrator services. Now here he will have different services like retriever, tool hub, okay, multiple tools it will be calling, and then memory, recommendation and guardrails. Guardrails means security and all, right? So after that, so from here retriever it will go to vector DB and then embedding service, LLM provider, and then monitor, evaluation and cost dashboard. And here memory, so user profile will come here, and for recommendation inventory APIs it will call inventory APIs. So this is the architecture. Now key design goals if you talk about here, so see, multi-model support, okay. Now you can call multiple LLM models here according to your requirement, and high availability, low latency, secure data access, cost control and continuous quality evaluation. Now let's talk about some follow-up questions. So we will be talking here about 16 follow-up questions, okay. We'll see answer from each role's perspective, means from software engineer, senior software engineer, and then architect. So the question is RAG architecture. If someone will ask about the RAG architecture to software engineer, what he will describe: RAG combines retrieval with generation. Instead of relying solely on LLM's training data, it retrieves relevant document and include them in the prompt, okay. So instead of sending directly request to LLM, we will just send the context to LLM and then he will answer based on that context. So what will be the flow? So question will get converted into embeddings, then it will search in a vector database. He will retrieve the relevant document, he will send that document to LLM, and then LLM will generate answer for us, okay, using natural language. So now senior software engineer, what he will say, that I would separate document ingestion, okay, embedding generation, indexing, retrieval, re-ranking, generation into independent component. This allows each stage to scale independently. Again, he is talking here about multiple services, okay. Like for document ingestion, okay, first time when you are putting document in a vector database, okay, so that is the thing. Then embedding generation, so your request will get converted into text into number, so that thing also, it will also get stored in the database, vector database. Then indexing, then retrieval re-ranking. Retrieval re-ranking means, let's say 100 documents is relevant, but the context window is limited, right? So you cannot send 100 documents. So from those 100 documents, it will re-rank and then will send LLM the top 5 documents, let's say. So that is the re-ranking, okay? And then and generation into independent components. Okay, now what architect will say, that he will say that I would support hybrid retrieval. Hybrid retrieval means vector plus keyword search. Okay, all these things I have explained in my AI video playlist. So you just go to AI video playlist, and then you can see all these things in the detail. Okay, and then a re-ranking model, document versioning, monitoring of retrieval quality, of continuously improving answer accuracy. Okay, so he will be using all these things: hybrid retrieval, and then re-ranking, and then document versioning. Document versioning means, today I have let's say in a banks or in healthcare sector. Okay, let's say I have ingest one document today. Now tomorrow I have a few more detail, right? So I need to ingest that also. So there the document versioning would be required. That earlier my answer was generated on based on document version number 1, and today my answer is generated based on document number version 2. So there I need to maintain the versions. Okay, now so follow-up to question would be product catalog indexing. Okay, so now what is product catalog indexing? So software engineer will say that convert product description, specification, FAQ, and reviews into embeddings and store them in the vector database. Okay, so that is the thing. So product catalog information you will store in a vector database. Now senior software engineer will answer that whenever a product changes, regenerate embeddings asynchronously through an event-driven pipeline instead of rebuilding the entire index. Okay, so here he is talking about asynchronous thing like Kafka or RabbitMQ you use, and then parallelly it will ingest the data. Okay. Now architect will say that I would implement incremental indexing with version control, support multiple embedding model, and partition indexed by product category for better scalability. Okay, now what will be the follow-up question 3? So it is related to embeddings. So now software engineer will say that embeddings convert text into numerical vectors. So semantically similar content is stored close together in vector spaces. Okay, so let's say if I'm talking about queen, okay, and then prince. So all these things are belongs to a royal family, right? So let's say the king's vector will be something like this: 0.21, 0.10, 0.8 dot dot dot. Okay, multi-dimensional vector is. So king is getting stored in database something like this. Okay, because text to numerical format. Let's say queen is getting stored in a database something like this. See, her vector will look like this. This is 0.21, 0.18, 0.8, 0.7, something like this. So this is similar. Okay, semantic search, because here we do semantic search. Semantic search means which all components are closer to that particular point. So now here this is 0.21 and this is 0.18, so this is more closer, right? And if I say banana, let's say, so banana's vector will be something like this: 0.3368, 0.4712. It is nowhere close to this king. Okay, so it is closer to this queen, so it will send this queen in a response. Okay, so yeah, so that is the concept. And then what senior software engineer will say for this is I would use the same embedding model for indexing and querying to ensure consistency vector representation. Okay, same embedding model he will be using for indexing also and for query also. Okay, now architect will say that embedding models should be evaluated periodically for retrieval quality. Okay, multilingual support, latency, and operational cost. For all these things you need to evaluate it periodically. Okay, the embedding models. Now follow-up question 4 is vector database. So vector database, software engineer will say that software engineer will say a vector database store embeddings and perform similarity search to retrieve relevant documents. Okay, I just told you what is similarity search here. Senior software engineer will say about vector database is that the database should support approximate nearest neighbor search. Nearest neighbor search means 0.21 and 0.18. Okay, so which is the nearest one? It will search that. Metadata filtering and horizontal scaling as well. Okay, now what architect will say about vector database? So I would choose the vector database based on scale, latency, replication, backup, and operational maturity while monitoring query latency and index growth. Okay, so he will say that on which factor he will choose the database. Okay, vector database. Now the follow-up question fifth is related to the personalization. Okay, personalization for each customer. Okay, each user is on personalized search, let's say. So software engineer will say that use what the customer likes. Okay, whatever you have liked it, just keep a note on that, and that what they search for, okay, what they bought before, suggest more relevant products. So the search history, you can say. Now, senior software engineer will say that instead of sending the customer's entire history to AI, send only the most useful preferences to make response faster and cheaper, right? Instead of sending whole history, just send the relevant data. So your responses will be faster and cheaper also, right? So now what architect will say here, that build personalization using recommendation system. Now here he is talking about recommendation system and relevant customer data. Two things, okay, while ensuring user privacy and following local data protection laws. Here he is talking about regulation as well. So that is the level of answer would be required from each role. Okay, now follow-up question sixth is related to hallucination prevention. Okay, so hallucination means AI sometimes invent its own answer. Okay, he doesn't know what is the, like today if you ask that who invented Java, so he will be saying Elon Musk, something like that. So that is called the hallucination. Okay, so and we need to prevent that, right? So for that, what you will do, that will be the question. Now, so what software engineer will answer for that is use RAG. So the model answer only from retrieved product information, right? RAG. Senior software engineer will say that restrict prompts to retrieved context. Okay, required citation where appropriate. So he is also talking about RAG. Okay, just retrieve information from the given context only. He is saying that citation where appropriate, okay, and avoid answering when confidence is low. So he will do confidence scoring. Okay, now let's say he doesn't know the answer, so he will maintain one score, and we will say that if the score is below this point, then your confidence is low, and then just say you don't know. Okay, instead of giving any answer. So now what architect will say for this is combined RAG, okay, guardrails, confidence scoring, policy validation, and fallback responses to minimize hallucinations. So he will talk about different perspective. Now the follow-up 7 is tool calling. Okay, now if you wanted to call some external APIs, okay, so what software engineer will say that tool calling allows the LLM to invoke external API for real-time information. Okay, real-time information. Let's say I wanted to call Google Meet, okay, to just check what all meetings I have scheduled for today. So your LLM is calling your external API of the Google Meet, right? So that is the tool calling, and here, so in this perspective, this shopping assistant perspective, you will have multiple tool calling, like order status API, inventory API, and shipping API. You need all the detail because you are creating separate services, right? So you can create them as a MCP, model context protocol, and then use that MCP. Okay, the other one will use your MCPs of these APIs. Okay, so senior software engineer will say that I would define clear tool schemas with the validation, execute tool only when needed, returning structured result to the LLM. Okay, so he will create a tool schema with validation, first thing. Second, he will use only when it is required. Okay, and then whatever returning structured result to the LLM. Okay, structured result, not the random one, but in a particular structure. So now architect will say that orchestration, the orchestrator should manage tool selection, which tool you need to call. Okay, you have a multiple tools here: retries, timeouts, authentication, and audit logging for all external calls. So now follow-up 8 would be related to MCP, okay, model context protocol. So this is what I just told you. Software engineer will say that MCP is a standard protocol that allows AI model to securely connect to external tool, API, and data sources using a common interface. Okay, so let's say you have created one model, and now you need to create a database. Okay, so you need to give separate configuration to connect that particular database, right? And or you need to connect to GitHub, you need to connect to Calendar, you need to connect to let's say Slack. Okay, so you need to give separate configurations there. Instead of giving separate configurations, there will be a standard protocol. Okay, so using that, anybody can connect with them. Okay, so that is the work of MCP. So MCP is a standard protocol that allows AI model to securely connect to external tools, okay, APIs or data sources. So now, a senior software engineer will say about MCP is that I would expose inventory, order, recommendation service as MCP compatible tools. Okay, he will expose these services only as a MCP. Okay, so different LLM can access them consistently without custom integrations. Right, so architect will say that MCP reduces integration complexity by standardizing tool access. Correct, one standard protocol we use there. I would implement authentication, authorization, versioning, and governance for all MCP servers. Okay, now follow up 8 would be multi-agent architecture. So here, let's say you are using multiple agents. Okay, so software engineer will say that different agents can specialize in different tasks. For example, you can have shopping agent, order agent, and delivery agent. So why you are having multiple agents here and not the single agent? The answer is very simple. I think we will see that you don't need we'll see that by the way, one agent, so the history will be very bigger, right? The context would be very bigger for one agent only. So it's better that create multiple agents and they will be responsible for their own task. Okay, so now senior engineer will say that I would introduce orchestrator that route request to a specialized agent based on intent and aggregate the results. Okay, so now you will have a multiple agent, so there you need to introduce orchestrator which will route request to a specialized agent, and then it will aggregate the result as well. Okay, from multiple agents it will aggregate the result and then give it to user. So now architect will say sorry. So now architect will say that use multi-agent system only when the clear task decomposition exists. Okay, like for example, shopping agent, order agent, and delivery agent are performing their own task. Okay, that is the clear independent decomposition exists. Okay, between them, so you can use agents there. The orchestrator should manage context sharing, okay, execution order and error handling and the cost. Of course, context sharing is important because for this agent you will give the required context only, not the whole context. Okay, otherwise what is the point of multi-agent? Okay, we can give all the context to one agent only and then he will reply us. Okay, so that is not the thing. So that's why here context sharing, okay, and then execution order, which LLM, which agent will run first or second, and then if any failure happen then the retries, okay, error handling, cost, okay, all these things he will be talking about, architecture. Now see here, you don't always need agents. Okay, like I was telling you, you will introduce multi-agent, but do you really need multiple agents? Okay, so for a simple shopping assistant, a single AI model with access to the tool is often enough, right? So for example, user is saying order an iPhone under 80,000 rupees. So what AI will do, it will search the project, it will check the inventory, and then it will place the order. That is the normal flow. So no separate agents are required here. Okay, when do agents become useful? So when the request involves multiple independent tasks, okay, that require different expertise. For example, I want to buy a laptop, compare three models. Okay, it will compare three models, apply the best coupon, check if the company discount is eligible, place the order, and schedule delivery after 6 p.m. Okay, so these kind of requests when multiple independent tasks are here independent task is like shopping agent. Okay, that is the one thing which will find and compare the laptops. Second one is pricing agent, which will find the coupons and discount. Okay, third one is order agent, place the order, and fourth one is delivery agent, which will schedule the delivery. So the orchestrator coordinates these agents and return the one final answer. So here you would be required multiple agents. Okay, now why not let one AI agent do everything? So this is what I just explained you. So see, the reason is the application become large. Okay, the prompt become very long, the AI has too many tools to choose from, then different tasks have different business rules, and it's harder to maintain and test, okay, by one agent. So specialized agents keep each responsibility focused and make the system easier to scale. So they will be focused on their own responsibility. Okay, so now follow-up question 10th is related to cost optimization. How you will optimize the cost here. So software engineer will say that here the concept of cache will come. Okay, instead of calling again and again database, just send the response from cache, right? So that is so cache is associated to cost optimization everywhere. So now cache repeated responses and avoid unnecessary LLM calls. Okay, LLM calls are chargeable. So now senior software engineer, what he will be saying that or if it is not chargeable, if LLM is your own, then it will require GPU and everything, right? All resources, so they will be chargeable. So now senior software engineer, what he will be saying that use a smaller model for simple tasks, cache embeddings, batch embeddings, jobs, and invoke larger model only when it is necessary for bigger tasks. Architect will say that optimize across the entire pipeline, prompt caching, semantic caching, model routing, token budgeting, response streaming, auto scaling, and continuous cost monitoring. So he will be talking about lots of things, first of all, just cache the prompt, okay, and then semantic cache, whatever semantic search you have done, cache that as well. Okay, then model routing also you can cache, token budgeting also you can cache, response streaming, auto scaling, and then continuous cost monitoring. These are required. Now follow-up 11 is total there are 16 follow-up questions. Okay, so now we are on 11th one. So that is related to prompt caching. Okay, the user is typing something, so we will cache that prompt as well. So software engineer store responses for identical prompts to avoid repeated LLM calls. See, if I am asking two questions, okay, we'll see the example here. Okay, so like means he's just saying that if the prompts are identical, okay, so no need to send to LLM, just give the response from the cache itself. Okay, the senior software engineer will say that use semantic cache, so similar question can reuse existing response when appropriate. So simple example we will be seeing here. Let's say user one without semantic cache, user one is questioning like what is the refund policy, okay, and user two is questioning can I return a product and get my money back. So he is also talking about refund policy. Okay, this is the semantic search, both are same, but if there is no semantic caching, then LLM will generate a new answer for first one, and then LLM generate the answer again for second one as well, right? But if you have cached the semantic, you have used the semantic cache, so he will know that okay, both meaning is same. Okay, so just return this answer itself. Okay, so with semantic cache, what is the refund policy? LLM generate the answer and store in the semantic cache. Second time when user 2 will question that can I return a product and get my money back, so in that case the system recognize that this question has the same meaning and return the cached answer instead of calling LLM again. So that is the flow. Now what architect will say about cost optimization? So he will say that implement cache invalidation tied to catalog update. Okay, so let's say your catalog has been updated, your product has been updated, so why to keep that in a cache? Okay, so update your cache also, just implement some cache invalidation strategies. Okay, and personalized cache keys where user specific context affect responses, right? Now when product information changes like price, stock, or description, the old cache answer should be removed as so the user don't see outdated information. And then if the answer depends on user, such as their location, membership, purchase history, okay, keep a separate cache for each user so everyone gets the correct personalized responses. Now the follow-up question 12th will be recommendation engine integration. Okay, so software engineer will say about this is that use a recommendation engine. Okay, recommendation engine means it will show that you have bought this, so you can buy this as well. So recommendation it will show. Okay, so use the recommendation engine to fetch candidate product and let the LLM explain why they match the customer's need, right? So now for example, if you bought the AC, let's say, okay, so so it will show that people have bought a stabilizer also with that, right? So that thing. Now, senior software engineer will say about recommendation engine is keep recommendation logic outside the LLM. Okay, don't integrate it into the LLM. The recommendation engine ranks product and LLM generate natural language explanation. Both are two different things. Okay, recommendation engine will be outside from LLM, so it will just re-rank the product that it will give it to LLM that these are the product which user can also buy, and then LLM will use its natural language for the explanation. So simple example, like user is saying recommend a laptop under 80,000. Okay, so recommendation engine, what it will do, which is outside the LLM, what it will do, it will search the project, apply the product, apply the business rules, rank the best option, and then return Dell Inspiron, HP Pavilion, and then Lenovo IdeaPad. So he will send all these three product. Now what LLM will do with this list? So he will turn the ranked result into natural responses, and then he will say that based on your budget, I recommend Dell Inspiron because it offers the best balance of performance, battery life. The HP Pavilion is good alternative if you prefer lighter laptop. Okay, so why keep recommendation engine logic outside the LLM? The reason is the recommendation engine makes accurate rule-based decision, while LLM only explain the recommendation in natural language conversational way. Okay, natural and conversational way. Now, what architect will say for this? The recommendation service remains the source of truth for ranking, right? The LLM should never invent product or alter ranking logic, so it should be outside. So everybody is saying the same thing. Follow-up question 13th is related to inventory lookup. Okay, how many products is remaining in the shop or something like that. Okay, so software engineer will say that retrieve real-time inventory using API instead of storing stock information in the prompt. Okay, so yeah, the value will change, right? So you have to get that in real time only. Senior software engineer will say that use tool calling to fetch live inventory only when required, reducing stale information. And what architect will say for this? Inventory system should remain authoritative, handle latency with retries, timeout, graceful fallback when inventory data is temporarily unavailable. So he is talking here about latency and fallback methods, and then authentication and all those things. Okay, so now follow-up question 14 will be related to security. So software engineer will say that validate inputs. Okay, whatever input you're sending to LLM or the vector database, then authenticate user who is sending this request. Okay, and authorize access before invoking backend services. What senior software engineer will take will say on security is that protect against prompt injection, whatever you are injecting. Okay, now validate tool input, sanitize retrieved content, whatever you have retrieving, you just sanitized it. Okay, any harmful words or something, you just remove it. And secure service to service communication. Now architect will say for this is implement defense in depth. Okay, what is defense in depth? Like IAM is AWS service, right? Encryption in transit and at rest. Okay, secret management, audit logging, policy enforcement, guardrails, and then regular security review. So he will talking about all these things. He will keep in mind all these things. Okay, while implementing. Follow-up question 15th is related to customer privacy. Okay, so software engineer will say that only retrieve customer data needed for the current request. Senior software engineer will say that mask sensitive information, avoid sending unnecessary personal data to LLM, and enforce access control, right? Architect will say that apply data minimization. Okay, only the required data, send it to LLM. Consent management, encryption, retention policies, regional data residency requirement. Okay, like this data will be here in this region only, it should not go to another region. Okay, then and comprehensive auditing to protect customer privacy. Follow-up question 18 will be related to evaluation metrics. So software engineer, how you will evaluate. Okay, so software engineer will say about response accuracy, how accurate your response is, latency, and then user satisfaction and successful task completion. Now senior software engineer also monitor these things. He will monitor, and apart from that he will also monitor retrieval precision and recall, hallucination rate, tool call success rate, cache hit ratio, cost per request, and token usage. Okay, so now what is retrieval precision here and what is retrieval recall here? here we have talked retrieval precision and retrieval recall. So retrieval precision means how many of the retrieved document are actually relevant. He has retrieved 100 documents, but how many are relevant? Okay. And retrieval recall means how many of the total relevant document of the system successfully retrieves. Okay, 80 documents were relevant to it, but out of 80, let's say he has sent only 60 documents. Okay, so easy example, suppose there are 10 relevant documents in the system. So your system retrieve 5 documents and 4 are relevant. Okay, one he just retrieved from here and there. So precision would be 4 by 5 means 80%. So most retrieved document are correct. Now the second thing is recall. So 4 by 10, okay, 40%. If found only some of the relevant documents. So this is the retrieval precision and retrieval recall. Principal engineer or architect will say about for enterprise AI platform. He is talking about AI platform. Okay, I would define business quality and operational metrics like customer task completion rate. Okay, second is product recommendation, click through and conversion rate. Okay, how many people have clicked it and how many leads have been converted, these all things. Then answer groundness and hallucination rate, retrieval relevancy, that is we saw precision and recall, right? And then tool invocation success and latency, end-to-end response latency, P50, P95 and P99 means for the initial, like P50 means 50% of the response will come into the 200 millisecond, let's say, and then 99% of the response will come into 150 millisecond. Okay, so something like that. Now token consumption and cost per request, cache hit ratio. Okay, prompt for prompt and embeddings. Here you are talking about prompt cache, embedding cache. Then customer satisfaction, CSAT, we are talking here, and then service availability and error rate. So these metrics would be tracked through dashboard and used to derive continuous evaluation, A/B testing and model improvement. So that's it. Thank you.